find the interior angle sum for a regular polygon, we can use the equation, the number of sides minus 2 multiplied by 180. Now we're going to see if that's true for just regular polygons or if that's going to work for any polygon. We saw with our regular equilateral triangle that we could take its vertices, slice them off, and arrange them to form a straight line. That showed us the interior angle sum was 180 because a straight line is worth 180 degrees. Now let's look at two other types of triangles. Here we have a right angle triangle. If all triangles have an interior angle sum of 180 degrees, we should be able to do the same thing. Take the vertices, slice them off, and arrange them in a straight line. And we see with our right angle triangle, we're able to do that. So that means this triangle also has an interior angle sum of 180 degrees. This one's a scalene triangle. Let's see if it can also be arranged in a straight line. Slicing off its vertices and arranging them, we can see that they do indeed form a straight line. So this tells us that all triangles, whether they're regular or irregular, are going to have an interior angle sum of 180 degrees. Let's look at a few other irregular polygons. To find their interior angle sums, we're going to create central angles. To create central angles, we put a point in the middle of the figure and draw the radii out from that center point to each of the vertices to create triangles. We can then use those triangles to find the interior angle sum. We know that each triangle is worth 180 degrees. So here on that quadrilateral, we have 4 triangles worth 180 degrees each to give us a total of 720 degrees. On our pentagon, we have 5 triangles worth 180 degrees to give us a total of 900 degrees. Then on our hexagon, we have our 6 triangles worth 180 degrees each to give us a total of 1,080 degrees. But this time, when we have that central angle, we created a circle that isn't part of the interior angle sum. We can see if we go through all of those central angles, we make a complete circle around. We know a circle is worth 360 degrees. So to find the interior angle sum of just the polygon, we're going to need to subtract 360 degrees from each of our totals. When we do that, back here on the quadrilateral, 720 minus 360 degrees leaves me with an interior angle sum of 360 degrees. On our pentagon, 900 minus 360 takes me back down to 540. And on our hexagon, 1080 minus 360 brings us back to 720 degrees. Let's take our data and arrange it on a table so we can look for a pattern. If we go through our final interior angle sums, we can see that we're still increasing by 180. However, we got there in a different way. For quadrilaterals, we started out by having 4 triangles that we multiplied by 180. So those quadrilaterals started out at 720. On the pentagons, our 5 triangles multiplied by 180 started us off at 900. And our hexagon had 6 triangles, so our hexagon started out at 1,080 degrees. Well, we need to take that data and still be able to generalize it to find an equation for a polygon with any number of sides. So our n-gon. Before, we came up with the equation number of sides minus 2 times 180. Let's see if that still fits. Well, we can see we're clearly still multiplying by 180. But here, instead of multiplying by the number of sides minus 2, we're simply multiplying by the number of sides. But this time we had an added step. We had to take all of our values and subtract 360 degrees. Well, if we think about that in terms of multiples of 180, 360 is the same as 2 times 180. So we have to get rid of 2 groups of 180. Well, instead of subtracting 360 at the end, what if we got rid of 2 groups at the beginning and did the number of sides minus 2 times 180? That brings us back to the same equation we've been working with. So whether you do it with central angles and subtract the 360 circle at the end, or whether you do it at the beginning by doing 2 less than the number of sides times 180, we're still going to come to the same conclusion. Interior angle sum of a polygon, number of sides minus 2, then multiplied by 180. Check out the other videos in our playlist and don't forget to click on subscribe. Thanks for watching!